Okay. On to chapter 3, numerically summarizing data. So what we had done before was we said, suppose you have all this data, how can you make a picture or some sort of visual representation of your data? Pie charts, bar graphs, histograms, frequency polygons, all that. Now the question is, we're going to, from here on out, assume that we have some kind of numerical data. So as we mentioned with qualitative data, you can't really do that much. You can say how many you have of each value, but you can't do things like take an average, etc. Liberal arts plus computer science divided by 2 equals gobbledygook. So we can't really do anything with it. With numerical data, we can do some serious analysis, and that's what we're going to begin with today, in a very simple way to start. So the first thing we're going to look at is the measure of central tendency, or in English, give me one number that represents all the data. So, for example, consider the number of math classes, like we said, question number 2 on the survey. If you go back to the survey we did on the first day, we talked about this last time, which question has numerical data. It was question number 2, how many math classes have you taken before? So, how can we sum all that information up in one number? And let me take one moment. To pull up that survey. Here we go. Okay. So the question is, how can we take all this data right here and sum that up and express that with one number? The average is a great way to do that. So presumably everyone here knows how to take an average. Okay. You add up all the numbers and divide by the amount of numbers that there are. So, for example, suppose you score on 3 tests 71, 75, 84. What's your test average? You would do 71 plus 75 plus 84 divided by 3, and that gives you, what is it? Okay, 76. So it's 76 2/3. So we're perfectly happy just rounding it to 2 decimal places. 76.67. Okay. So now let's figure it out for the number of math classes. So with the number of math classes, what did we have? There. 0, 0, 0, 1, 1, 1, 2, 2. So you would have 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then 2 2s. And then what do we divide by? Right, the total. So what was the total? 10, 11, 2, 23. So we take this and divide by 23. Now we just have to figure out what that is. Sorry? The total is 15 divided by 23. So 15 divided by 23, that's like 0.62 or something. So I like to use my spreadsheet as my calculator. Equals 15 divided by 23. Okay. I'll just take that to 2 decimal places, so you get 0.65. Okay. So there you go. So the average number of math classes taken by you guys before this class is 0.65. But the mean is not the only number that we can use to say that here's one number that represents all the data, or a measure of central tendency. Another one that you may have heard of is the median. So the median its nickname is the middle number. Now to give you a simple example, suppose you score on 3 tests 71, 75, 84. What's your median score? 75. Okay. So now by saying the middle number, here's a nice way to interpret that. It has to be in order. Absolutely right. So that's one of the implications of this statement. So first of all, okay. So what if I said your test scores were 71, 84, 75? What's the median? What's the median? 75. The median is 75. Right. It's not. Doesn't matter what order you write them down in. Right. In numerical order, which one's in the middle? And the way to interpret this is to say that half of the median is 75. Half of the time your score was above 75, and half the time your score was below 75. Okay. Put it in order. Okay. So let's look at one. And 1, 2, 3, 4, 5, 6. Okay. So what's the median here for us? Yeah. So it's 1, and how could you figure that out from looking at the data? Yeah, the number that's in the middle. How do you find the number that's in the middle? Right. So there's 2 different ways to do this. One way is, I like to say, just the cross-off way. So if you're looking for the middle number, you can cross off the 2 n numbers, and the middle number is still going to be the same middle number. Does that make sense? Okay. Cross off, cross off, cross, 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 cross. Both really good questions, which I'm going to answer in the next 30 seconds. And there you go. So there's your median. So the median is 1. Okay, so 2 really good questions. I'll handle the second one first. What if you have an even number of numbers? You take the average of those 2 numbers. Exactly. Okay. The median would still be 1. Absolutely. That's exactly right. Which is actually really important. We're going to come back to that in a minute. Okay. So what about here? So I also took a survey and I got the heights of different students in inches. So notice that just so you have an idea, 60 inches is 5 feet and 72 inches is 6 feet. So most of these heights are within that range. Okay. So what is the median height? Well, once again, we could do our little cross-off thing, but what someone said, what if you have 1,000 numbers? Quite right. So here's the way to conquer that problem. How many numbers are there here? Okay. So there are 19 numbers. So here's the trick to find the middle number. Let's see. Now, obviously, you could go about the crossing off, or think about it for a second. If there are 19 numbers, how many numbers are you going to want to cross off on each side? You're going to want to cross off 9 numbers on each side. Does that make sense? Okay. So we're looking for the number in which position? The 10th. We're going to cross off 9 numbers. So we're looking for the number in the 10th position. And that's it. So you find the number in the 10th position. Instead of going back and forth one by one. So you just count 1, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. There's your median. All right. So now instead of having to necessarily reason it out, there's a quicker way to do this. There we go. There are 19 numbers, so we want 19 plus 1 divided by 2. 20 over 2 is 10. So we know we want the number in the 10th position. 19 is how many numbers there are. Okay, so why do you do the plus 1? Yeah. It's hard to lay out exactly it's hard to explain clearly why there's a plus 1, but hopefully you see that we sort of figured it out just by counting that we're supposed to get the number in the 10th position. So you can see that using plus 1 works. So why do we use it? It kind of has to do with the fact that we're crossing out the median number, so we have to account for that. There's no clear explanation that I can give that will be understandable. It'll take me less than 15 minutes. But hopefully you see that it works. Doing the plus 1 works. If you don't do plus 1, you get 19. You get 9.5. So that couldn't be right. It always works. Yeah. Right. You always add 1. And so, of course, what if you have an even number of numbers? Suppose you had 20 numbers. Suppose you had 20 numbers. You would get 20 plus 1 would be 21 divided by 2 would be 10.5. So what do you do with that? Then how do you find the median? Yeah, 10.5 means you're between what? Means you're between the 10th number and the 11th number. So you take those two numbers and take the average. There you go. So there you go. Okay, is that straight? Alright. So next, there's another measure of central tendency. So mean and median are the two main ones. There's another one. The mode, the most common number. Okay. So for example, if you go to, first let's look at our class number of math classes. What was the mode there?
1.
The mode was 1. There were 10 zeros, 11 ones, and 2 twos. The mode is 1. What about for the heights, what's the mode? How many 64s are there? How many 66s are there? 2 modes. Exactly. Well, for mode, no, mode is specifically asking what's the most common number. You wouldn't say the most common number is 65. That doesn't make any sense. Most common number is 64 and 66. It's a tie. Okay. Now, what about with the other example that I gave? Your scores were 71, 75, 84. What's the mode? Yeah. All of them, none of them. Typically we say none of them.
So when there are two repeated numbers, it's not a mode.
Sorry?
When there are two numbers that repeat themselves, there are a couple more than one, then it's not a mode.
No. If every number appears the same amount,
Right.
then we say there's you could either say they're all the mode or none of them are the mode. We're going to say none of them are the mode. Okay, so here are the 3 measures of central tendency. The question is, which of these should we use and why? Yes. Yes. You use them all. It depends. Right, exactly. Well, let's take a look. So I did this survey one time, number of credits taken. So I got this list for number of credits taken. Let's see. What's the mean? Oh. Add them all up and divide by 20. In the interest of time, I'm going to try to do this from memory. The mean was approximately 28. Okay. What about the median? Median we can figure out, not too much trouble. How many numbers? How many numbers are there? Okay. So if there are 14 numbers, what do we do? Right. That's right. So if there are 14 numbers, 15 divided by 2 is 7.5. So what does that mean? Right. 7.5 is between the 7th number and the 8th number. So 7th number and 8th number are right there. So what do you do with those two numbers? 27 plus 32 divided by 2 gives you 29.5.
How is that better than 7.5?
I'm sorry?
How is that better than 7.5?
No. 7.5 is not a number of credits. What is 7.5? It's the place, exactly, or the position, right? Nobody took 7.5 credits. It's what is the 7.5 number? Right. Okay. So now if I said how many credits were taken, well, if I said on average 28 or the median was 29.5, that looks like a reasonable estimation of this data. What's the mode? The mode is 0. Is that a reasonable estimation of this data? No. Right. This is the reason that this is one demonstration of why the mode is the least used of these. Okay.
Alright, I see how you really can't use the mode in this one, right? But what's the example of something you
There are many cases where you can use the mode. It's typical. Well, not always, but often the mode is actually somewhere in the middle of your data. But that's not always true. That's the thing.
So you
Um,
can't.
Okay. Yeah, that's actually the thing. Sometimes the mode will be the lowest number. Sometimes your mode will be your highest number. Sometimes the mode will be somewhere in the middle. Sometimes there'll be two modes. So it's interesting, but if you were going to give one number to summarize all your data, the mode probably would not be it. So now we're talking about the mean and the median as the two best measures. Now, the mean and the median are both used very frequently. However, you'll notice that most people just, you guys immediately responded, how do we summarize the numbers? Oh, we use an average. And you said that immediately. But what I want to point out to you is that there can be a problem with the mean. Okay. I'm going to take a survey in this class without taking a survey. I'm going to say, what is, I want to find out everyone's salary in this class. All right. I'm not going to go around and ask everyone how much you make. So let's just make up some reasonable data. There are probably some people in here who are students full-time and don't have a job. So there are going to be a couple people whose earnings are zero or close to it. Then there are probably going to be some people who have a part-time job, work in the bookstore, whatever. So those people we're probably going to have a bunch of people earning $5,000, maybe $10,000 a year. Those are people working part-time jobs. Then there are going to be some people working full-time or nearly full-time, but also clearly you're in school. So those people might be making something on the order of $20,000 to $30,000 a year. There may be one or two people who have a stock trading job on the side that making $150,000, but I'm guessing not. So I'd say that would be fairly representative of what the students in this class are making. So what would be an average salary? Some people making 0, some people making 5 to 10, some people making 20 to 30. So what I'm going to say is that the average salary in this class is around $15,000. The average. Okay. Oh, look, it's Bill Gates. Bill Gates is coming to visit our classroom. Isn't that nice of him? You guys know how much Bill Gates makes?
40 billion.
He's actually worth $40 billion approximately. Bill Gates approximately makes $1 billion a year.
He makes like what, 150 an hour?
That makes no sense.
Okay.
I mean, everything.
Okay. So, we're going to save the discussion for whether or not this is fair for another time. Bill Gates earns about $1 billion a year. Bill Gates and his $1 billion salary walk in the room. What is the average salary in this room now?
Something that's
Well, you take $1 billion plus all the couple dollars that we make, and we divide it by like 25 or 30. The average salary is now $35 million. So my question is, does this make us all millionaires? Clearly not.
That's basically a point to show us that average is not.
The average can be misleading for this reason. Now, my next question is, Bill Gates and his $1 billion salary walk in this room, what is the median salary?
it would be it wouldn't be Bill Gates.
Absolutely. It's still around $15,000. Because if you line up all the salaries and take the number in the middle, it's still going to be approximately $15,000. Having having just $1 billion figure on the end does not really affect the median barely at all.
Would it not affect the low median?
Probably not, unless two people are making $1 billion. Right? No, it wouldn't affect the mode. Okay. So right. Oh, that's not what I want. So right, so I call this the Bill Gates effect. That's a fancy little name. What this really is that Bill Gates' salary is an outlier. That's what this is called. It is a value far away from most of the data. Now notice, when you bring in an outlier, what happens to the average? The average shoots up. What happens to the median? It barely changes. So how do we? That should be clear. There's a term for this in statistics. We say the average is not robust with respect to an outlier, but the median is robust. Robust means not affected by.